So we're just going to discuss some properties of related angles. So some special properties of related angles, all angles that are related, and I'm going to denote them theta 1, theta 2, theta 3, theta 4. To denote the quadrants, the subscripts are the quadrants. What we know for all related angles is that the absolute value of sine will be the same. The absolute value of cosine are going to be the same. The absolute value of tangent, provided that we're in the same family. We have to be in the same family. The absolute value of tangent will be the same. And by extension, if you know the sine theta of an angle, you can get the sine theta values for all angles that are related to theta. You just need to pick apart which ones are positive and which ones are negative. So this is also important for a given trigonometric ratio, sine, cosine, or tangent. Only one family has that specific ratio. So earlier we took a look at the 30-degree family, and we noticed that the sine value of that 30-degree family was either positive 1/2 or negative 1/2. It's only the 30-degree family that has this sine value, no other. So let's take a look at this next example. We're going to calculate all related angles of 153. So very quickly, I'm going to sketch this out. 153, we've done this before, so 153 is in quadrant number 3. So I'm just going to make this circle, so it's quadrant number 3. I'm just going to put those dots there. How far away is 53 degrees away from the closest x-axis? Well, we are, well, if I add 7 to that, 27 degrees, I believe. So if I know that I'm 27 degrees away from the closest x-axis, the quadrant 3 solution would be 180 degrees plus 27, which would yield 207 degrees. And that would be my theta 3 solution. My theta 4 related angle, well, that is going to be all the way around 360, that's the closest x-axis, minus, then I need to back it up, how far? 27 degrees. So my theta 4 related angle is going to be 330 degrees. So here are my 4 related angles. Now, let's jump to B. Given that cosine is 153, or sorry, given cosine of 153 degrees is this ratio, identify the angle or all angles. Now that's sort of misleading because there is only one angle. Identify all angles from 0 to 360 that have the same cosine value. Well, that's a good question. Well, we know that only related angles will have this specific cosine value in absolute. Moreover, this is a negative cosine value. This 153 is in quadrant number 2. I am going to put it to you, where is cosine also negative? Well, cosine is also negative in quadrant 3, is it not? Because cosine is x. X is negative in quadrant 2 and 3 over here, right? So really, what we're looking for is we're looking for the related angle in quadrant 3. I wish I would have found out that already. And indeed, if I look above, what I have is my related angle in quadrant number 3 is going to be 207 degrees. Now, you can test that out, and it's incredible, right? That indeed that this works. Let's move on to the next example. Now remember, there's going to be exactly two angles with a cosine value of negative 0.537. So what I've underlined there is what is known as the trig ratio. So this is the first thing that I think is quite important. I'm going to draw the unit circle. There it is. This is a symbol. It only helps my thinking. And then I'm going to ask myself a very simple question. Where is cosine theta? Negative. Now, in which quadrants? Now, I might have to think here, cosine is negative, well, in quadrant number 2 and 3, right? Cosine is x, whereas x negative 2 and 3. So what I'm going to do here is I have quadrant 2 and quadrant number 3. Those are going to be likely my solutions. Well, they will be. But now I'm going to take a look at the trigonometric ratio itself. I'm going to reach for a calculator. I know that's probably surprising to you. And I'm going to do some algebra. So I have cosine theta is equal to negative 0.537. The next thing I'm going to do is I am going to apply the operation that gets rid of cosine on the left-hand side. If I'm able to eliminate cosine on the left-hand side, what's going to happen is that I'll be left with a theta. Now, what is the inverse or the undoing of cosine? Well, naturally, that's inverse cos. And perhaps I should have, let me just do that again. I'm sorry. It's correct, but I'm just going to write it a little bit different. So cosine theta is equal to negative, I'm going to leave a space there, obviously, 0.537. And let me try that again. I'm going to try to isolate theta. So I am going to apply inverse cos to both sides. And the reason for that is because in equation, and generally if we do things, the same operation on both sides, still maintains its equality. But what I'm left with on the left-hand side is theta. Theta is going to be equal to inverse cos negative 0.537. So, quickly take out my calculator, punch in that number or punch in those operations, and what I should get is theta is equal to 122 degrees or 22.480 degrees, if I round it to 2 decimal places. So the output of the calculator gives me my quadrant 2 solution. So that's really fabulous. So now I can simply find my quadrant 3 solution, and I'll leave that, press pause, and feel free to figure that out yourself. Okay, if you're coming back, what you'll notice, I believe, is our solution is 237.520 degrees. I'm just going to create a summary statement. Therefore, theta is equal to 122.480 degrees and 237.52 degrees. All right, and really that's it. So let's go over what the question said. Let's find all angles between 0 and 360 that have this cosine ratio, where cosine theta is equal to negative 0.537. What I did initially is I located where my cosine values are negative in quadrant 2 and 3. So naturally, I know that my output should have 2 angles. My solution should have 2 angles. And by the way, this picture that I just highlighted is likely the most important part of the question. Otherwise, I'll tell you what happens. So we have the trigonometric ratio. I apply the algebra to both sides the inverse trigonometric ratio, which leaves theta isolated. So where here theta is isolated, and I get my quadrant 2 solution. My experience simply says that if somebody does not draw this triangle, they forget that there's a second angle involved. Anyways, let's move on to the next question. All right, solve for theta. 0 to 360, so 0 to 360, I'm just going to draw that. My mistake, 0 to 360, yikes. Where sine theta is equal to negative 0.421. So I ask myself, where is sine negative? Sine is y. Where is y negative? Y is negative in quadrant 3. In quadrant 4, I simply make a mark on this part right here. It's all good. So this little picture helps me out. And then I reach over and I write the equation again. Sine is equal to negative 0.421. I apply inverse sine to both sides of this equation to isolate theta. I'll put that in brackets just for fun. Now I have theta is equal to the inverse sine of negative 0.421, and reach for my calculator. Let's all reach for our calculators together. It gives me a seemingly nonsensical angle that theta is equal to minus 24.8. Yikes. I'm going to round this to 3 decimal places. That kind of day, having a hard time. 898 degrees. Now, notice that I should have a quadrant 3 solution. I should have a quadrant 4 solution. This angle, this negative angle, does indeed have a sine value of negative 0.42. However, it's important to note, we're looking for only angles between 0 and 360. So, how far is, or maybe number one, what does negative 24 degrees look like? It looks like that direction. But it doesn't change the fundamentals. How far is negative 24.898 away from the x-axis? Well, it's 24.898. So how do I get my quadrant 3 solution? Well, it's 180 plus 24.898. What's my quadrant 4 solution? Well, it's going to be 360 minus 24.898 degrees. Right? Because you would have to go all the way around 360 and then simply subtract it. So my angle, or therefore, theta is going to be, I'm going to write this as a nice summary statement. I hope it's nice. 204.898 degrees, or 335. Oops. .102 degrees. All right, that was fun. Stay tuned. I'm sure there's one.